Hey Toros, it's that time of year again. Are y'all ready for Family Super Bowl Science Night at 6 p.m.? Hey, before we get started, we gotta make sure that we're safe. Anytime we play some sports, anytime we do anything with science. So, make sure you have your kit. Make sure you have your goggles, protect your eyes. Make sure your gloves are protecting your hands at all times. And always have your apron to protect your clothes. Once you have all these things and you check your kit, you're ready to go. So my question is to you, are you ready for some Super Bowl Science Night?
Toros! Toros! Let's get ready for this virtual science family night! Toros!
Hello, guys. Welcome to Family Science Night. We are very excited to have you here at Jones Middle School. This event is hosted by our Title I program here in Aldine ISD. Remember, to sign to win prizes, you need to sign in right here in the Google chat, right? With the Google form. I am very excited. We have lots of experiments, and this is going to be great. Sorry about the technical difficulties in the beginning, but this is going to be an amazing event. Remember, in order to win prizes, you need to participate, answer the questions, and have your safety, your apron, your goggles, and be ready for kickoff. So right now, we're going to go ahead and get into our first quarter. Let's go. Let's get it started.
Guys, welcome to Cyber Family Science Night. I am Mrs. Hines Jones.
And I'm Miss Washington.
8th grade team. All right, so we got the first quarter. We're going to take the ball and we're going all the way down the field with it. All right, so y'all ready? Here we go. This activity, this is going to be a demonstration of a rocket launch, okay, which will focus on Newton's 3 laws in motion. This is our T 8.6C. We're going to investigate and describe applications of the 3 laws. Okay, the first law states that an object at rest tends to remain at rest, and an object in motion tends to remain in motion unless acted upon by an unbalanced force. The second law states that force equals mass times acceleration. Whereas the third law, this is going to be where you have that action that takes place, and for every action, there is an equal but opposite reaction. All right, so we're going to go ahead and gather up our materials. Everyone should have their activity bag. So you have a film canister, okay? We have some wings. All right, you should have 3 pieces of those. You have a spoon. Yep. You have some tape. And you have Alka-Seltzer tabs, okay? You should have all of the bag. You will need to get your own water. So we do have a small little jar of water. You just need maybe a small cup of water. I'm going to pause for about 10 seconds to make sure you go and grab that water. Okay. You ready? You ready? All right. Okay, so let's go ahead and get started. Like Coach said, safety is first, right? So we're going to put on our goggles. We're going to protect our eyes. All right, make sure you have on your aprons. We have on our aprons, and you are working on a flat surface, okay? Now pay attention. You have to complete each step with us. And I want you to involve your family members. Get your family members involved. Make sure you take pictures and use that Twitter, okay? We want to see it. So first, we're going to go ahead and put the wings on, and you're going to follow Miss Washington. She's going to show you exactly how to do that. So we're going to start with the body of the rocket, which would be the bigger piece. She's putting it on the front of the canister. And show them that the bottom is open. So the way you put it, make sure the canister is open at the bottom. Okay, there you go. She's using her tape to make sure she secures her body on her canister. Now she's going to go ahead and put wings on there. You have to tape, okay. Okay, hopefully everybody is moving along. Okay. All right, so now we have our rocket. Quick demonstration, really quick. I want everyone to pay attention to Miss Washington. You have to make sure when we do this, you have the cap down, okay? The cap is going to be on the flat surface. See? On the flat surface, okay? So now we're going to hypothesize. In the chat, okay, tell us what you believe will happen once the water comes into contact with the Alka-Seltzer, and what do you think will happen to the rocket? Remember, you have to participate in order to win those amazing Super Bowl prizes. Go ahead and put it in the chat. We'll wait a few minutes. Okay. What do you think will happen? Well, don't say it.
I'm not quite sure. I'm gonna put it in the chat too. Okay.
Okay.
Don't look for my answer though.
All right. And if you want, you can name your rocket as well. Should have named our rocket, huh?
We should have.
Yeah. Okay.
We can name it after a Texans football player.
No, we can name it after a Saints football player. Okay. All right. So I want everyone to really pause and listen really quickly to this. All right. After you add the water, you will need to quickly cap the canister, turn it down. You want the bottom of the canister to be on a flat surface, and then you're going to back away, okay? And then you're going to back away, okay? All right, so now we will start. So break Alka-Seltzer in half. You're going to grab one tablet, break it in half, okay? And then you're going to take one of the halves, break that in half. That's going to give you a fourth of your Alka-Seltzer. And you're going to put that inside of your canister. Right? Put it inside your canister. Now, here's that part where I say you want to make sure you move quick after you do it, okay? You're going to take a spoon of water, just a spoon of water, and you're going to drop it inside of the canister and hurry up and cap it and turn it upside down so it can stand up, step back. It's coming. Should we count it down maybe? 5, 4, 3, 2, 1. 1. Did anyone happen? Do we need more water? Well, she had a rocket in her hand. Are you okay?
Yeah. Okay, guys. Technical difficulties happen. I'm gonna redo this really quickly. I'm sure y'all's went off perfectly because y'all are amazing scientists. I'm just gonna toss this back in here and see if we can get it to go off for you guys the way it was supposed to. So let's try this again. Y'all can't see it, but I can see it bubbling.
Yeah.
And I'm hoping it's going to go off in just a moment. If not, that's okay. These things happen in science. That's why we do multiple trials.
Okay.
And I guess it doesn't want to do it today.
It's
Damn.
being so mean. Okay, that's okay. It happened.
Okay, good.
Okay, that's cool. All right, so really quickly, I want you to not just talk about ours, our experiment, but talk about your own. What were some observations that you had? Tell us in the chat, how do you think Newton's laws applied? How do you think maybe the first law applied? Okay, I want you to give us your observations, and I want you to tell us about Newton's first law. Okay? Go ahead and wait for that really quickly. That was pretty good, though.
I know.
It was pretty good.
It always waits till we're least expecting it.
Look, you.
Oh, our rocket bounced out of it. Let's rebuild while they're typing in the chat.
Okay.
We got to do some construction, guys.
Okay, so while she do that, let's go over Newton's first law. All right. So Newton's first law applies to the rocket launch because it is acted upon by the unbalanced force inside the rocket, right? It remained at rest until those bubbles formed or that gas took place, okay? So I want you to tell me the second law. How does the second law apply? That force equals mass times acceleration. I want you to think about that, okay? Think about the Alka-Seltzer tab. Okay, give you a few minutes, few seconds, I'm sorry. Remember, these comments in the chat are worth something, so make sure you are participating. All right. All right, so talking about Newton's second law. Hopefully some of you put it in before I go on, but the mass of that Alka-Seltzer directly affected the force of the rocket, which is going to either increase or decrease the acceleration, okay? Then you got the third law. That's that action and reaction piece, right? That action and reaction. Well, we saw a lot of action and reaction take place. So I want you to give me your own description. What do you think just happened as far as Newton's third law? Okay, so remember Newton's third law, that is going to be that action and reaction. You actually had an action take place when the bubbles begin to fizzle, and then that reaction was what? It took off, okay? So good job, everybody. Good job. Are y'all ready for your second trial? Are you ready for your second trial?
I'm ready for this second trial.
Okay, we're going to do better the second time.
All right.
All right, we just have to do better the second time. We're not going to let science defeat us. Okay, so everyone, go ahead. You're going to go ahead and take a half piece of that Alka-Seltzer. So you should have one piece that you did not make any smaller. So you should have a half piece, just like Miss Washington. Put that inside of your canister. You're going to add a spoonful of water. All right, we're doing this again. And quickly cap it. Turn it upside down. Step back. It's gonna go. It's gonna go.
This one is all about timing, y'all. You gotta be a little patient for science. Yeah. Remember, it doesn't want to move. Right, it doesn't want to move until that unbalanced force acts upon it. So we gotta. Sometimes you gotta wait for your force.
You got it. It's good. So really quickly, I want you to discuss the difference in your two trials. So you had the first trial, right? Clearly, we used two different pieces of Alka-Seltzer. I want you to discuss that. And then I want you to tell us, how did the change in mass affect the acceleration? Okay, when we're talking about that acceleration, we're talking in these terms. Let's say the height. Did the first one go higher, or did the second one go higher? Go ahead and give us those amazing responses in the chat, because once again, those responses are golden, and it can take you all the way to the Super Bowl. All right. Good job, everybody. 8th grade team, we did awesome. We did. We had the best rockets. All right. All right, guys and girls, thank y'all for doing this with us. We appreciate you.
Back to Miss Prosper.
Hello, guys. Welcome back. How awesome was that with the blast off experiment using Newton's laws and everything? So this was the end of our first quarter, and it was amazing. We have so much more experiments left for you guys to join. But guess what, guys? I have a question. What is Newton's third law of motion? I want you guys to go ahead, put your answers in the chat. remember, you need to participate in order to win, right? What is Newton's third law? And as you guys are writing your responses, we do have a few winners of this beautiful Chick-fil-A gift card, okay? We have actually 2 winners. Our first winner is Logan Estrada. Logan Estrada, you are the proud winner of a Chick-fil-A gift card. We also have Aaliyah Moore. Aaliyah Moore, thank you for logging in and participating. You are also the proud winner of another Chick-fil-A gift card. Students, remember, in order to win, I know some of you are having some difficulties signing in using the Google form, but you need to ensure that you're using your Aldine ISD email address, okay? If you're using another email address, it's going to block you out. So you need to ensure that you are using your Aldine ISD email address. This is really exciting. So let's answer another question. What is Newton's second law? Come on, guys. I know you were listening to Ms. Heim-Jones and Ms. Washington, and they did an amazing job. So what is Newton's second law of motion? That's my second question. So I'm going to give you guys a couple seconds to go do that. Okay. I have one more question. What is Newton's third law of motion? How is that going, guys? Thank you guys for participating. Remember, we just getting started here at Jones Middle School Family Night, Toro Land, and we are just really happy to have you guys here with us, okay? The whole team is here. All your science teachers are here. Real quick, rep your science teacher. We know a lot of you are joining us, but we don't know who your science teachers are. So please put your science teacher's name in the chat. And we're getting ready to go into the second quarter because, you know, it's Super Bowl, right? Super Bowl Family Night. All right, y'all. Thank you guys for participating. Remember, you got to listen up to the questions so you can listen up to the experiment so you can follow up with us. With that being said, let's get ready for the second quarter.
Welcome. Thank you guys for coming to Jones Science Family Night. I'm Mr. Norman. We have
Mr. Code.
And we're going to have some fun tonight. But let's get to some ground rules. We want to make sure safety is the number one thing. Make sure you have your aprons on and your goggles because it's going to get a little messy. So, Mr. Cole, can you tell us about this experiment that we're doing today?
Definitely will there, Mr. Norman. The first thing I want you guys to do is go into your elephant toothpaste kit, please, the bag, and open it up. You're going to have to get out your bottle like this with the hydrogen peroxide and soap solution. You're going to need to get out your yeast. And what I need you to do before we continue is get yourself a little bit of hot water. It doesn't have to be hot, just warm water, just tap water. And right now, tell you what, I'm going to give you about 20 seconds to go and get a little bit of water in your little cup here.
So
yours looks like this.
Use this time right now to get the water for the experiment.
We'll wait right here.
We're thankful for everyone who's here. We see all the comments. I'm glad to have my students. I see a couple of them. Jay, great. I see you in the comments. I'm happy to have my students as well as Mr. Cole. We got two of the best science teachers at the school, but we're not going to discredit none of them because the science team as a whole, we're all great.
All right, guys, we're going to assume that you've already come back with your cup. It doesn't need to be hot water, just tap water. If it's warm, that's even a little bit better. Zoe, Carla, David, hope you guys are behaving. I know you're not. All right. Now what we're going to do is we're going to take our yeast package here. Yeast is a living thing, guys. It is a fungus, and it reproduces by budding. We're going to take our yeast, and we're going to pour it in your cup of water, and we're just going to stir it a little bit. It's going to kind of turn into paste. What we're trying to do is get the yeast to wake up and come back to life. Just going to take a couple of minutes. Once you've got that done, we're just going to set it aside.
So at this time, we want you to be stirring. You should be stirring the yeast in your water.
Once it kind of turns into paste, you can just set it down. It should be kind of milkshake watery. All right. Guys, today we're going to be going over TEAC 7.6. chemical and physical changes in matter. So, first question we need to ask ourselves is just to remind ourselves, while this is waking up, just going to take a minute, is what is matter? What is matter? I'll let you post something up in the chat for a second. All right, if you said that matter is anything with mass and anything with volume, you're absolutely right. Mass is can be a solid, it can be a liquid, it can be a gas. And all matter has physical properties. Physical properties is how we describe matter. It's important to understand and recognize physical properties. So we know when we've had a chemical reaction. That's going to come up in a second. Let's take this Alka-Seltzer tablet. If you can see that, what are some physical properties of that? Go ahead and post it up in the chat if you want. I'll give you 10 seconds to do so.
And we know that the physical properties are the physical appearance on the outside. Tell us what, looking at this, what do we notice? Tell us what we notice about this.
All right, we've got, it is round. Yes, it is. It is round. That's its shape. We've got it is white. That's right. That's its color. That's a physical property. Yes, it is smooth. I don't know how you know that. Maybe you've had some experience with Alka-Seltzer tablets. It is smooth. It is solid. Good, good. These are the physical properties of this tablet. Now, take a look at this cup of everyday water. Kind of hard to see. Water. Good old H2O. What are some physical properties of the water? Go ahead and post it up in the chat. I'll give you 10 seconds to do so. About 5 seconds. Come on, David. There you go. All right. It is a liquid. Excellent. That's its state of matter. It is clear. Good. It is tasteless. Excellent. No shape. Good. Good. Now, usually when we mix two kinds of matter together, nothing happens. It's boring. Kind of lame. However, sometimes if we mix the right kind of matter together, we get a chemical reaction. That's where matter reacts with matter. And this causes a chemical change. This will cause changes in physical properties. And we know we've had a chemical reaction if we see a change in some of the properties, a change in temperature, or a release of gas. So let's see what happens if we put this Alka-Seltzer tablet in our water.
You hear that, Mr. Cole? Do you hear that?
I can hear it. I can even smell
something's happening. How do we know a chemical reaction is happening? Right? Type in the chat. Tell us what's going on. What do you see? What do you hear?
Bubbles. Good. That's a release of gas. And yes, we can actually smell it from here. It's getting a little colder. Good. I don't know how you know that, but that's a change in temperature. That's evidence of a chemical reaction. And that's what you're going to be doing at home in just a second, but it's going to be 10 times cooler than this. So let's get ready with our chemical reaction elephant toothpaste style. What we're going to do is we're going to go ahead and we're going to take our bottle. And we are going to unscrew the lid. Do you have your goggles on? And I don't mean over your forehead either.
And safety is number one. Make sure you have your goggles over your face. Make sure you have your apron on. Make sure you're doing this with adult supervision if possible. Make sure you are being safe. We want to see you all back here tomorrow.
I'm going to get this out of the way. And you should have a container, either a metal or a plastic pan. And I want you to go ahead and put your bottle in the pan, in the tray or whatever we've given you.
Once you've got the bottle in the pan, everyone give a thumbs up in the chat. Let us know that you're on track with the experiment. We want to do this on the same track. We want all of us to have fun together.
¿Estamos listos? Then we'll begin. What I want you to do right now is you are going to take yours that look like this. You are going to take your yeast, which has been soaking in water and has now come alive and ready to release oxygen. And we are going to add it to our, wait, Zoe. And we're going to wait. We're all going to do it together. And we're going to look for evidence of a chemical reaction, evidence of gas being released or a temperature change. Are we ready?
Are you ready, kids?
You say,
I can't hear you. Are you ready? Let's go.
count it down, Mr. Norman.
5, 4, 3, 2, 1.
Pour it in and let the magic happen. Oh my goodness. Whoa.
And there you have.
Do we have a chemical reaction going on here? When's it gonna stop?
What's happening on your end? Type in the chat what you see on your end. Tell us what's going on your end.
I hope you're not doing this near a carpet, guys. Mr. Norman, would you say we have a chemical reaction going on here?
Yes, sir, Mr. Code, I would.
We have gas being released.
Yes.
We have a temperature change.
Feel a little warm to me.
Don't touch the phone, guys. It's hydrogen peroxide in there. And I'm going to make sure we wash our hands thoroughly after we do this activity. Now, it might still be going. We're going to set ours aside because we've got another little special treat in store for you. So you want to leave yours where it is because we don't want it to spill while it's still reacting. That is elephant toothpaste. Do not brush your teeth with this toothpaste, even if you're an elephant. That's hydrogen peroxide and laundry soap, and it's not too pleasant.
So, Mr. Cole, what is this we have right here? What is this? This is something crazy, is it?
Well, Mr. Norman, it turns out that the hydrogen peroxide that the students are using at home is 3% hydrogen peroxide. And I was thinking, what do you think 30% hydrogen peroxide might do in our elephant toothpaste reaction?
I don't know, but I would love to see that.
And we used yeast as a reactant to release oxygen into our soap and create the foam and the bubbles.
Yeah.
I thought we might just want to try elephant toothpaste on steroids and use something called potassium iodide.
Oh, I see you going, Mr. Cole. I see what you got on your sleeve.
Well, you're not going to try and stop me, are you?
Oh, no. I'm going to listen. You can have it.
I knew you wouldn't. That's why you're my partner. Here we go, guys. Let's see what happens when we bump up from 3% hydrogen peroxide to 30% hydrogen peroxide, and we go from a weak oxidizer like yeast to a powerful oxidizer like potassium iodide.
And one thing we want to say, do not try this at home. Let the adults, us, the supervisors of the school, let us do this.
Matter of fact, we might just have to put it inside our container as well. Larger reaction, larger container. Let's see what happens. I don't even feel like measuring this out carefully.
Man, let's not.
Count it down, sir.
5, 4, 3, 2, 1. Let's go.
Uh-oh, it isn't stopping.
Oh,
Mr. Norman, what have we done?
Oh, we done made something. We done something wrong. They gonna.
We're getting fired.
We're not gonna be working here no more after this.
Sorry, kids. You might have a substitute teacher for a little while.
And it keeps going and going and going.
Is that smoke, Mr. Norman?
Oh Lord, we gotta call the fire department. Oh, we didn't do it. Y'all didn't see us do this.
Can you see me over? You said that we have a chemical reaction, Mr. Norman.
Definitely a chemical reaction. It was kind of cold. It's warm here.
It is very warm. We have a gas being released. We have a temperature change. We might have the fire department pretty soon. So I think what we've shown is that when we have a temperature change and a release of gas, we have a chemical reaction.
Yes, we do. I hope you, all right, give us a round of applause. Everybody in the chat, give us a round of applause.
And it didn't spill. Mr. Norman, you're the man.
We want to thank y'all for coming. 2 of the best people at the school. We hope you enjoyed it.
Not true. You're the best people at the school, guys. You're the best. Toros! You
And we're back. Like, how cool was that? Oh my goodness, Mr. Code and Mr. Norman, they did such an incredible job. And we are very excited, you know, because we have you all. You guys thought this was it? No, it's not. We have many more activities in store. Okay, with that being said, I have a question because I know this was a cool experiment. What is a chemical reaction? I need to see responses. Okay, we did 2 chemical reactions. What was a chemical reaction? We want to know. I know Mr. Code told you guys what it was. We definitely need to know what a chemical reaction is. Remember, kids, in order to win, you have to participate. Please put your questions, your answers, in the chat. This is the only way we can know who's saying what. With that being said, from the first quarter, we have our winners. We have the proud winner of another Chick-fil-A gift card, Angel Vera. Okay, Angel, you are the proud winner of this Chick-fil-A gift card. And then we have Miss Jasmine. You are also the winner of this mouse, okay? A wireless mouse, like cool prizes, right? A wireless mouse. This is amazing. We have another winner, Rodrigo Acosta. Guess what you're winning, Rodrigo? A wireless speaker. Oh my goodness, like great prices at Science Night. Science Night is amazing. Okay, are you guys having fun so far? Please, and remember, guys, you need to tweet your pictures out. We want to see what you're doing at home. We want to know what's going on. Please tweet us out, okay, at JonesMS_AISD. Parents, please, I know some of our students do not have a Twitter account, but you can tweet us out as well. Remember, this is Family Science Night. We don't just want to see students. We want to see students and parents together, you know, and we're just excited here at Jones. I have another question, okay, and this question is going to help you out moving forward, right? What are some of the evidence of a chemical reaction we observed with Mr. Code and Mr. Norman? I'll give you a couple minutes to think about this. What are some of the evidence of a chemical reaction that you observed with Mr. Code and Mr. Norman? If you said bubbles, that's right? Bubbles are evidence that a gas is being released, okay? So remember, if you are a 6th grader, you're going to be doing this same experiment in a couple weeks, maybe in the next 2 weeks. If you are an 8th grader, you're going to be definitely doing this in the next 2 weeks. Okay, so everything we're doing in Family Night, it is all related across all grade levels, and we are just so excited. With that being said, I want to give a shout out to our curriculum director for science. She also donated some of our prizes, and we are so grateful for her donation to our Family Night. I want to give a shout out to the science department for their hard work. Parents, they really worked hard on this, putting this together for us, and we are super excited. With that being said, we are getting ready to start our 3rd quarter, right? This is football. Remember, kids, you need to answer the questions in the chat. And let's get to it.
Hey guys, welcome back. That was a cool experiment, wasn't it?
That was awesome. I thought Mr. Code's experience was like mind-blowing.
I know, that
cool.
was super cool. I enjoyed that. All right, guys, so we're going to get started on activity 3, our density column. So go ahead and get your stuff out of your activity 3 bag.
This is your last activity set, so it should be the last one in the box.
All right, so first, if you do not have gloves on yet, you are going to want to put on gloves because your hands might get a little dirty. So let's put on our gloves. Everybody should have gotten a pair of gloves in their box.
We're working with all sorts of different liquids today, so we don't want our hands to get sticky or oily for all the different things that we're working with.
All right, so let's go through and make sure we all have everything for the density column. So first, you're going to want to make sure you have your plastic tube. Okay, so put that onto the side.
The next thing is our different liquids. So you should have a corn syrup container. You should have an oil container. Dawn soap. Mine is green, but yours might be blue. Rubbing alcohol.
Some of y'all's may be yellow or orange.
And then the last one is water. You're going to need some water. So at your house, either from your sink or the refrigerator, go ahead and get a small bit of water that we're going to need for today.
All right, guys. So we are going to be working with different liquids today. and more specifically with the density of the different liquids.
So the TEAC for density is 6.6b. The student knows matter has physical properties that can be used for classification. So we are going to be able to identify an unknown substance with these different densities.
All right, guys, so I want y'all to look at all the liquids that you have in front of you, and I want you to kind of move them around in the cup that they are in and look at the consistency of the liquid.
Do they move fast? Do they move slow?
All right, so with the ones that move more slow, do you think those would be more dense or less dense than the ones that move around a little easier? So I want y'all to put your cups in order of which you think is the most dense liquid to the least dense liquid. And we'll see if y'all get it correct as we add them to our tube.
I don't know, Miss Murphy. I'm kind of stuck between the corn syrup and the Dawn soap. They kind of both move a little slowly.
They
but
do.
I'm not too sure what's going to go first.
Also, the alcohol and the water are kind of similar too, as well as the oil. So I don't know, this might be a little difficult. All right, so I want y'all to notice on your tube that it goes from 0 to 50, and that's gonna represent milliliters. So since we have 5 liquids, we're gonna wanna fill up each liquid 10 milliliters. So we're gonna start with our most dense liquid, and we're gonna go from the bottom of the tube to the 10 milliliter line.
So how about in the chat, we put what you think the most dense liquid was?
All right, if you put the cornstarch, then you were correct. That is going to be our most dense liquid.
That makes sense to me. It does move really slow. So.
Yeah, I think that makes sense as well. Okay, so the consistency of this is a little thicker than the other liquids. So let's go ahead and pour that in up to the 10 milliliter line. So you're going to want to be very careful with this.
This one is very sticky, guys, so try not to get it on your gloves or your hands or anywhere else, whatever you're working on.
All right, so there we go. I got the cornstarch into the 10 milliliter line. So we're going to put the cap back on, and then we'll put that to the side.
Our next substance that we're going to put in there is Dawn soap. If you thought Dawn soap would be the second most dense liquid, then you were correct.
Okay, so we're going to fill this up from the 10 milliliter line to our 20 milliliter line. So very carefully add it to the 20 milliliters. All right, guys, so if you notice, the Dawn soap is laying on top of that layer of cornstarch. Why do y'all think that is?
Remember the subject that we're talking about right now. Would the Dawn soap be more dense or less dense than the corn syrup?
If you said less dense, then you are correct, okay? So the Dawn soap is going to be less dense, and that is why it is on top, laying on top of our cornstarch.
Alrighty, so our third substance is our water. The water that you should have gotten from either the sink, the fridge, your water bottle, anywhere at home.
All right, so we're going to very carefully pour the water from the 20 milliliter line all the way to our 30 milliliter line.
That's so weird.
All right, so if you notice, it kind of mixed a little bit because I wasn't that careful pouring it in, but it's starting to separate, and you can see the separation between the dish soap layer and our water layer.
So now we have the water in this tube and the water sitting on top of everything. So that means the water is the least dense substance in that tube right now.
All right, guys, so we have 2 liquids left. We have our oil, and then we have our rubbing alcohol. So I want y'all to tell me, which one do you think is gonna go next? Our oil or our rubbing alcohol?
Remember to look at how fast they move, the consistencies of them.
All right, if y'all said oil, then you are correct. Our oil is gonna go next. right, so we're gonna pour from our 30 milliliter line to our 40 milliliter line very carefully. And if you notice, you can already start to see the separation between the water layer and our oil layer.
I definitely do. I see a clear line that separates all of the layers.
Awesome. All right, guys, so our last liquid that we have is our alcohol. Okay, so you're gonna wanna be very careful with this, and then you're gonna place that right on top of our oil.
So why are we putting the rubbing alcohol last? What do you think? If you said it's because the rubbing alcohol is the least dense, you're right. You got this.
Awesome. So now y'all should have your complete density column, and you should be able to see the clear separation between all of our different layers. There you go.
Make sure that you do not shake this, guys. If you shake it, it's gonna get all blended together and you won't be able to clearly see the separation between the substances anymore. So keep it still, keep it on a flat surface, don't shake it all up, okay?
All right, guys, so now I want y'all to put in the chat and tell me what density is, okay, and what makes something more dense than something else. All right, guys.
That was awesome. I really like that experiment.
I did
That
too.
was cool.
That was fun.
Okay.
Good job, guys.
Hello, Toros. I'm Miss Brown, one of the assistant principals here at Jones Middle School. I want to thank you all so much for joining us tonight for our third annual Science Super Bowl. We could not do this without you and the support of our Toro parents and our amazing Jones science teachers. I want to send a special shout out to our amazing digital design teacher, Miss Brashear, who's been making the magic happen behind the scenes, along with all our backstage science elves. And to our awesome librarian, Miss Holloway, I see you, who's been monitoring the chat. And last but certainly not least, to our phenomenal science skills specialist, Miss Prosper, who came up with our vision for tonight. Her incorporation of fun and learning has truly set the tone. Toros, tonight you all have been blasting off and aiming high to reach the stars as you experimented with rocket launching with Newton's laws. We had fun with matter, looking at chemical reactions as you made elephant toothpaste. We learned about density, determining which liquids were more dense as we created density columns to see the different layers. But Toros, it's not over yet. After all, this is the Super Bowl. We have one more amazing experiment left. This will be for the Super Bowl prize. Get ready, Toros.
Hey guys, all right, it's Miss Washington again. I'm back here for the fourth quarter. We're gonna finish strong, all right? So I've got a really cool demo for you guys. You do not have this in your kit because it's a little dangerous to send home for you. So we're gonna do it here in the safety of our laboratory, okay? So I'm gonna go ahead and show you this. First, safety, right? Always start with safety. I'm gonna put my goggles on. I've got my official lab coat and my apron to protect my clothing, okay? Make sure that's good. I have a few things here. So if you are in 6th grade or 8th grade, you're probably talking about this. We're talking about chemical formulas, okay? So this is gonna be chemistry. I have 2 chemicals here. I have my powder, which is manganese dioxide, MnO2. And I also have my hydrogen peroxide, which is H2O2, all right? So go ahead in the chat. If you know anything about chemical formulas or you recognize these chemicals, go ahead and put what you know in the chat. I want to see what y'all got going on. Maybe what you think is going to happen when I mix these two, okay? Now, the importance of this experiment, I want you guys to pay attention to the evidence that chemical reaction is happening, okay? Remember, this is the Super Bowl. This is the big win, okay? So whoever gets that in the chat is going to be our winner. But make sure you wait until I've done the experiment. Okay, don't just start putting stuff in there. All right. So I'm going to start with my manganese dioxide here. I'm going to take just a very, very little bit. Okay. when you're doing experiments, you want to be very careful because these things could be highly volatile, okay? I'm gonna drop in my little bit of manganese dioxide, okay? I'm gonna cap this up so I don't get anything in there. Whoops. Go ahead, set this off to the side so it's not in any way of my chemical experiment here. I'm gonna grab my hydrogen peroxide, okay? Normally, you would not pour directly from the container, but there's very little left in it, so that's why I'm gonna do it tonight. But typically, you would have this in a separate container, okay, guys? All right, so again, I'm going to pour very little, and I'm gonna actually drop this down a bit so y'all can see this reaction here. I want y'all to see what's happening, okay? Are y'all ready? I'm gonna give a countdown, okay? In 5, and 4, and 3, 2, and 1. I'm pouring slowly because I want to be careful. Woo! Okay, y'all. Look at that. Ooh, I'm trying to make sure y'all can see me here. Did y'all see all that smoke? Oh, wow. This is, y'all can't feel it, but this is warm. I might not be able to even touch that. What do y'all think? What's y'all's evidence here? Somebody put in the chat, what is the evidence that y'all saw happening in this chemical reaction? What is the evidence that you saw going on in there? Okay, I'm seeing some good answers here. Good answers. Okay, make sure that you're putting it in the chat. This is for the big win, for the big win. All right, so we're going to go ahead and swing it back over to our lovely host for this evening so she can go ahead and talk about what we've got going on for the rest of this evening. Thank you, guys.
And we're back. Who knew Super Bowl Science Night could be so much fun? Thank you, Ms. Washington, for such an amazing demonstration of a chemical reaction. So remember, Ms. Washington stated that we need to state what are the evidence that we observe, okay? I would like you guys to put at least 3 evidence of chemical reaction in our chat, okay? Remember, it's about what you could see. There, Mr. Code and Mr. Norman in their experiment, they also spoke about chemical reactions. And remember, guys, science is not perfect, okay? Remember, you can purchase the same supplies and do it again and, make it even better than what you did today. And this live stream is also going to be recorded, so you can go back and you can view the experiments and you can do it again. If you were not able to receive a kit, you can also get the supplies and do it on your own with your family. With that being said, I believe it was the second quarter, we asked a question about the chemical changes. And we have a beautiful winner of a $25 Visa gift card. And that would be Miss Marissa King. Thank you for answering the question and participating with us. Remember, guys, you can pick up your prizes tomorrow with me, or you can go to the front office and they'll direct you. They'll put you in my direction so you can get your beautiful prizes. Also, we have another winner from our second quarter of a Family Feud game. Yoslin Salazar, you are the winner of this. And if you are virtual, if you attend school virtual, remember you can always come up to the front tomorrow or on Monday next week, and they'll notify me and you can come pick up your gift. With that being said, I have another winner of a Chick-fil-A gift card. This would be David Martinez. Chick-fil-A gift card. Okay, a Chick-fil-A gift card. I believe it's a $5 Chick-fil-A gift card. But thank you guys for participating and joining us and putting your beautiful responses. Everyone cannot be a winner, but we have a few winners. And again, ensure that you have your responses for the evidence of a chemical reaction. That's who's going to win the Super Bowl. And what is the Super Bowl prize? Another $25 Visa card. And we have a Google at-home speaker. Some great prizes at family night. And we have this, I believe it's a phone sanitizer. Okay. So this is the Super Bowl prizes that we have. With that being said, we're going to end with our prize winner. And again, parents, I want to thank you for joining us here in Toroland Jones Middle School. for our family science night. We really do appreciate everyone who has participated. I want to give a special shout out to my beautiful science team. They work so hard. Shout out to Miss Lewis, Miss Tiffany Lewis. She really put a lot of energy in this with me. Shout out to Miss Brown, the assistant principal of the department. Miss Brasher for putting the whole production together. And all my 7th grade science team, 8th grade science team, 6th grade science team. Miss Haggerty, the front office, Mr. Pruitt, Miss Martinez for my announcement. Everyone who has really helped us in this process, I truly, truly appreciate you guys. Thank you, parents, for motivating our students. And with that being said, our grand prize Super Bowl winner is Anisha Fisher. Shout out to Anisha Fisher. And you can come and collect your prize at any time, and we will be right here. So, guys, I'm sorry to leave. I know we were having a lot of fun, but this is it for us here at Jones Middle School Science Super Bowl Family Night. Let's go.